Hey guys, let's continue with quadratic equations. Today we'll be learning about finding roots. Now roots defines as per the graph. We could see that these two x-intercepts or zeros, so located here, these are called the roots. Or basically what happens here is within a graph you would expect it within a parabola you would see to intersect within either 2 or 1 point of an x-intercept. So for instance we have two x-intercepts, so we have one placed at -2 and one at +6. Now with that we could say that these are our given x-intercepts, and we could find this as well from a given equation, and that is how we're going to form our x-intercepts today, or the roots. So let's head up with a simple example here. So using our prior knowledge from the previous lesson, let's see if you can do it more. So we have x squared plus 5x plus 6. Now in this case, how I told you that, let's first label each and every variable. So we have 1 here, that's always a coefficient, so that's a, this is b, and this is c. Now we have a, b, and c. Now I told you last lesson that the product of c, so that's 6 here, has to, so there has to be two numbers that multiply to get c and two numbers that add to get b. So in this case we would have 3 and you would have 2, and we can simply write it as x plus 3 and x plus 2. Another way we can derive the same thing, but takes longer though, but looking at mathematical logic, let's apply it. So we have x squared, so we have these two numbers that add up, so it's the same thing as 5x, but just simplified even more. So x squared plus 3x plus 2x and then plus 6, and from here we can factor it on. So we have x plus 3, and then you have plus 2x plus 3, and from here whenever we have two pairs, let's knock out one and have one remaining. So that's x plus 2 and x plus 3, and we derive the same factorized outcome. Now with this x plus 2 and x plus 3, we know that they always equate to 0 for a given equation. So we can simply find the roots or the values of x by equating each of the x solvings, x expressions with 0 to find the individual and respective values of the x. So we have x plus 2 and we have x plus 3, and make sure you always equate this to 0 to get their own values. So in this case x has to equal to -2 because x goes out here and 3 goes out here as well, so then x also becomes -3. So that we have x plus 3 and x plus 2, x is equal to -2 and x is equal to -3. So the coordinates of this would become, so since x is -2, -2 comma 0 and -3 comma 0. So these are our coordinates of x.